So hello everyone. Today we're going to be talking about the flow time analysis, which is the topic before the last topic. So we only have two topics left, and this is the first of the two. So last week we talked about a process, and for example, we took the check-in at an airport process, and we said there's customers flowing in, customers flowing out. And we said there is a very important parameter. We mentioned three parameters, R, I, T, and T is going to be basically the time an average customer it takes for an average customer to move from the beginning of the process towards the end of the process. This is T, and this is flow time. And so flow time analysis is basically the analysis of T. So that's what we're going to be covering in this presentation. So why do we do flow time analysis? So first of all, the customer is going to value it because customers don't want to spend too long in a process, whether it's a check-in process or maybe doing a banking transaction. If that's the process, also customers wouldn't like to spend too long in it. Also in production, if you have shorter flow time, then it's going to be reducing the inventory needed, and all the different processes that depend on that processes will be relieved. So it's gonna help with all operations. Also, when it comes to product development and design, the faster you could design your product, the faster time to market. And feedback and correction, if there's any corrections or feedback, also it's faster to do it if you have shorter flow time. So in this presentation, basically we're gonna be talking about reducing flow time and the factors managing flow time, and we're going to be really also talking about the critical path in a process or in a system, because the critical path is going to decide which activities should be targeted when we want to reduce process flow time. So as mentioned, we have the flow time and critical path. That's what we're going to start talking about. Then we have the theoretical flow time, which is basically the flow time if we weren't to wait, if there was no waiting involved. And then we're going to be talking about tools and managing how to manage theoretical flow time. So you might remember the critical path from COM 225, where you had different paths and you identified the path which is the longest turned out to be the critical path. So here's an example of a series of activities in a process, and we have two different paths, this path right here and this path right here. If we sum all the times around this top path, we get 5 plus 20 plus 15, so that's 40 minutes, while the bottom one is 30, 35, 50. So right away we know that the longest path is this path right here, which so that would be the critical path. So this is the critical path. So in the critical path method, all we're doing is we're identifying the different routes or paths, and the longest path is going to be the critical path. So why is the critical path so important? So let's look at three different paths here. If let's say this path takes 15 minutes, this one 25 minutes, and this one 30 minutes. Now the 30-minute path is going to dictate how long the process is. So if we want to reduce the process time, that's the path we need to tackle. This path is what we need to tackle. The other two paths, if we try to reduce the time on the two other paths, it will not affect the time for the whole process because it would still be 30 minutes. So we care about the critical path because it's the longest path, and it's very important because this is the path we want to concentrate on if we want to reduce the overall process time. So let's do an example on the critical path. So we see this process which has a set of activities, and these activities are right here, and there's a flow time for each one of these activities. So there's a flow time for each one of these activities. Now what we want to do is identify the different paths in this process, and obviously there's this path right here, and then there's this path right here. Now what do we do now is we calculate the length of each path by summing all the different times, which are right here. So let's sum all the difference. So for path 1, we just add up the times, 20 plus 25 and so on, and we get 120 minutes, while the other one we sum and we get 150 minutes. And obviously path 2 is the critical path because it's the longest. It's quite simple. It's always the longest path is the critical path. So the flow time of the process is basically determined by the critical path. So the flow time of the process is 150 minutes because everything needs to wait for that path. So if let's say we have maybe 3 other paths that are not critical, it becomes not important how long they take, because no matter how soon they finish, it will not affect the whole process because the overall process is dictated by the critical path. So the flow time of the process is always the critical path time when it comes to critical path questions. So now that we've done an example on the critical path, we move on to the next subtopic, which has to do with theoretical flow time. Theoretical flow time. And at this point, we want to go deeper to understand what a flow time is. So let's say you're going to do a banking transaction at a bank, and that's the process. So your process is bank transaction. So there is, inside that bank transaction, that process, there is some form of waiting time. Whether you're standing in line to do the bank transaction, or even if there wasn't a waiting time and the banking assistant is probably making a phone call to get some information for your banking transaction and so on, all that time is waiting time. So our flow time actually includes 2 things: the activity time plus whatever the waiting time is. Now, so the theoretical flow time is the one without the waiting. So if we were to take flow time and take out waiting, that would be the theoretical flow time. And that would be exactly then equal to activity time. It would be exactly equal to activity time. So the theoretical flow time is exactly equal to activity time, or the time of the process without any waiting or interruption. Sometimes we're interested in knowing what proportion of the flow time is actually due to waiting. That brings us to the concept of flow time efficiency, which basically compares the flow time which include waiting to the theoretical flow time which does not include waiting. So flow time efficiency is basically this equation right here, where it relates the theoretical flow time to the average flow time. So this is a good equation to remember. Remember, your exam is going to be open book, so you could summarize the notes yourself, have them with you when you want to do the quiz and the exam. So this equation is important because it's gonna, so if a question gives us flow time efficiency, then we would be able to find out the theoretical flow time and the average flow time. Or sometimes the question might ask us for the flow time efficiency, and as long as we know the theoretical time and average flow time, and remember the difference between the two is weighting. Right? So the theoretical flow time does not include weighting, while the average flow time includes weighting. So let's do an example on theoretical flow time. Now remember, this is a good time to pause the video and try to do the example yourself. So the flow time for the process is 150 minutes, while the critical path of the process takes 60 minutes. Now, so the critical path, 60 minutes, is the longest path, so the process should be finished in 60 minutes, right? But the fact that it finishes in 150 minutes, basically tells you that there is a lot of waiting in the process. So let's compute the flow time efficiency. So for flow time efficiency, we have this equation right here, where it is the theoretical flow time over the average flow time. So the theoretical flow time is going to be the smallest of the two, because when you take out weighting, it's going to be a smaller number. So it's 60 minutes. While the average flow time is the longest, which includes weighting, is 150. So right away, we identified the different components, all the different ingredients we need for the equation. We go 60 over 150, and it's going to give us 0.4. So the efficiency of the process is 40%. So far we said that the flow time is equal to some theoretical flow time plus weighting. But the theoretical flow time itself is made up of value-added activities and non-value-added activities. So even the theoretical flow time in itself is broken into value-added adding flow time activities and non-value-added flow time. So if we take the theoretical flow time, so if we have 10 minutes theoretical flow time, maybe 2 of these 10 minutes are actually non-value added time, where you're doing something that doesn't add any value from the customer point of view. Now, it's very important to understand the definition that value-added activities is from the customer perspective. It's not from the producer perspective, it is from the customer perspective. So before we go on to talk about the management tool for theoretical flow time, let's just elaborate a little bit more on the difference between value-added activities from the customer perspective and the producer perspective. So for example, let's look at inspection. So inspection might be a value-added activity from the producer point of view, because when you're inspecting product, you're making sure that you're not sending poor product to the customer, which basically means that you have to pay some warranty, you have to ship the product back, and so on. So the producer might think of it as a value-added activity. But from a customer point of view, inspection doesn't add anything to the product. It doesn't make the product any better. It doesn't improve the design of the product. It doesn't do anything of that sort. So when we're doing process mapping, is we basically have to remember the difference. We have to focus on the customer point of view. So if you ever have a question where you have many different processes and you have to eliminate some non-value added processes, you have to think about the customer. Does that process add any value to the customer? Does it make the product better from a design point of view, from a finishing point of view, from a service point of view? If not, then it's not value added activity. So now, what tools do managers have to basically managing theoretical flow time? So, so first of all is we want to reduce, obviously we want to reduce flow time. We said from the beginning, it's very important to reduce. So flow time T, right here, we want to reduce it as much as we can. And there's many things we could do. First of all is move work off of the critical path. So we know the critical path is going to take the longest. So try to move work from the critical path to other paths, and that's going to shorten the overall time of the process. Reducing non-value added activities. As we said, the flow time, we have a time for flow time, and part of that is waiting and theoretical, and even the theoretical part of it is value added and non-value added activities. So we want to take out the non-value added activity, or at least reduce them. Reduce the amount of rework. This is very important because rework adds into the overall time of our process. Because we could, if we don't do any rework, we could use those resources to actually work on the process, and especially to work on the critical path. Modify the product mix. Sometimes changing how the product is might reduce the time. Obviously increase the speed of operation is one point, very important point. Crashing resources, we've seen that in Comp 225, where when the activities take too long, then we use overtime to reduce the time. So that's an example of increasing the speed of operations.